Okay, in this lesson, we're going to look at basically applications of word problems that involve geometry. And I know geometry is a scary word for most people, but it's not the geometry you're thinking of. It just means that it involves geometric shapes, finding areas and perimeters and volumes and things like that. So here's a typical example that has nothing to do with geometry, right? First thing we want to do is, before we get to the geometry stuff, we want to look at formulas, because a lot of geometry stuff deals with formulas, and then be able to work with those formulas, because sometimes we need to solve for a different variable than the one they're already solved for. So d equals rt, we all know that's distance equals rate times time, but maybe we want to solve it for time. Well, that's easy. All you have to do is divide both sides by rate, right? And you get time equals distance over rate. Same thing with this one. If we want to solve this for y, we isolate our variable, which means we subtract the 5x the other side, and then we divide everything by 2, and we get y equals 6 minus 5 halves x, which really is kind of the slope-intercept form of a line. If we write it like this, negative 5 halves x plus 6, and we know that this is the slope of our line and this is the y-intercept if we want to actually graph the thing. Here's another example. Celsius equals 5/9 Fahrenheit minus 32. And that's how we can find the temperature in Celsius degrees if we're given the temperature in Fahrenheit, if we want to go the other direction, right? So this would be if anybody else in the world was visiting our country, because we're pretty much the only people who still list temperatures in Fahrenheit degrees. They would take the Fahrenheit degrees, they would put it in this formula, and it would tell them what it is in Celsius, which makes more sense to them because they understand the Celsius scale. However, if we were traveling anywhere outside of the U.S., and we looked online and it says, hey, tomorrow it's going to be 22 degrees Celsius, you're like, okay, does that mean I'm wearing shorts or a parka? Well, then you would want to solve this for Fahrenheit so you could plug the value in for Celsius and get an answer, rather than plugging in a number here and then having to solve for F, right? So if you just solve for F once, then you could use it over and over and over again. Okay, so pretty easy, right? If we want to solve for F, get rid of the fraction. So we have 9c equals 5, F minus 32. Then we can divide by 5 to get rid of this one. So we have 9/5 C equals Fahrenheit minus 32. And then, of course, add the 32. So we have 9/5 Celsius plus 32 equals Fahrenheit. And now you could plug something in for C and get an answer for Fahrenheit. If you do end up traveling and you're in a country or an area that involves Celsius and you want to figure out what it is in Fahrenheit, an easy kind of rough estimate, and it's a pretty close estimate, is just take the Celsius measurement, double it, and add 30 instead of 32. Because you can see 9/5 is a little less than double, 32 is a little bit more than 30. So if we double it and add 30, kind of the over and under kind of outweigh each other, and you get a fairly accurate thing. So like I said before, when they said it was 22 degrees Celsius, you double that, which gives you 44. You add 30 to it, and it tells you it's going to be 74. And you go, ooh, that's nice, perfect, balmy weather, right? So that's just a little handy tip if you are ever traveling anywhere that gives you stuff in Celsius. Okay, on to the geometry stuff. So this is going to come into play when we have word problems that involve geometric shapes. As I've said before, when we're solving word problems, we always want to read it all the way through, kind of figure out what the theme of it is. When we recognize the theme is geometry-based, i.e. it's talking about perimeters or lengths or widths or areas or volumes, or anything that deals with kind of a geometric shape, you're thinking, okay, I'm going to need to know what those formulas are for whatever I'm looking for, perimeter, area, et cetera, et cetera. And it's probably going to be a really good idea to draw myself just a rough little sketch, a rough little picture of the shape of the thing I'm dealing with, so then I can go back through the question, pull out all the pertinent information, and label everything. So it tells me the length of a rectangular lot is 1 meter less than twice the width. If the perimeter is 190 meters, find the length and the width. I go, okay, well, I'm dealing with a rectangle, so I'm going to go ahead and draw me a rectangle. It says find the length and the width. So I don't know what length and width are, so those are just going to be L and W. Now I can go back and I can read everything and translate it. The length of the rectangle is 1 meter less than, well, remember less thans are always at the end, 1 meter less than twice the width, 2w. Perfect, okay? Perimeter is 190, so perimeter equals 190. But I have to know, okay, well, what is the perimeter? Well, that's easy. That's just 2L plus 2W. Well, I can't solve 190 equals 2L plus 2W because it's got two variables. I need to do a substitution. That's the big trick to these things. When I have two variables, I have to sub one out, or we can use the addition elimination method when they get more complex, and we learn that method later on. But for now, especially since they defined one of our variables in terms of the other, right? Anytime it's solve for a variable, and by solve for a variable, that just means one of the variables is all by itself on one side of the equation and everything else is on the other side. So in this case, L is all by itself. So we say it's been solved for L. And that means in the other equation, wherever we see an L, we're going to put all of this junk in its place. So that means we're going to have, I'll put it over here, 190 equals 2 times L, but L now becomes 2W minus 1, and then we still have the 2W at the end, this piece here. And now it's just a matter of solving this using our simple order of operations, right, where we get rid of parentheses by doing the distribution. So 190, it's a 9, equals 4W minus 2 plus 2W. Combine like terms, 190 equals 6W minus 2. Isolate our variables, so add the 2, 192 equals 6W, and then divide by 6 to get our final answer of W equals 32. Once we know what W is, right, this is 32, you can plug it in here. 2 times 32 minus 1 gives me 64 minus 1 gives me 63. I know my length is 63, and I found both dimensions. I can double check it, right, and know that 63 plus 32 is 95, and then these two are going to be another 95, and of course that gives me 190, and it fits the scenario. Let's look at another example. Two complementary angles are drawn such that one angle is 4 degrees more than 7 times the other angle. Find the measure of each angle. So again, I would go, oh, it's measures, it's angles, it's talking about that kind of stuff. That's kind of a geometry thing. I'm going to need to know some formulas possibly. Now I'm going to draw myself a picture. So here is an angle and two complementary angles. Now you have to know what complementary angles are. So instead of formulas, you need to know a little vocabulary. Complementary angles mean they add to 90 degrees. Supplementary angles mean they add to 180 degrees. And the way I always remember that is complementary is alphabetically before supplementary, and 90 comes before 180 in the numbers, right? So complementary goes to 90, supplementary goes to 180. That's how I memorized it. So here's my picture, right, where these two angles create a 90-degree angle. And I need to find the measure of each angle. So I don't know what these are. This is X. And this one over here, one angle is 4 more than 7 times the other. So this angle, right, is 4 more than 7 times the other angle. So this is just 7x plus 4. And then because they are complementary angles, I know they have to add to 90. So 7x plus 4 plus x equals 90, 8x plus 4 equals 90, 8x equals 86, right? And then that seems wrong. Is 4 more than 7 times, that's right. Add together, that's 8 plus 4. Subtract 4 is 86. I'm only thinking it's wrong because it's not a whole number. All of their examples seem to always be whole numbers because when you divide by 8, you get x equals 10 and 2/3, right? 6 divided by 8 is 10.6 repeating, which is a big fat pain in the butt because then you have to multiply that by 7 and add 4 to it to figure out the other one. But in any case, you understand how the process works. All right. Next one angle in a triangle is twice as large as the smallest angle. The third angle is 10 degrees more than 7 times the smallest angle. Find the measure of each angle. So, okay, I've got a triangle, so here's my triangle. I've got my angle, so here's X, Y, and Z. And I'm going to let them go small, medium, large. It might not match my picture, but I don't care. I'm just going to go alphabetical for small, medium, and large. If you want to, you could call them S, M, and L. One angle is twice as large as the smallest angle. So if this is my smallest, I'm going to let this be 2x, twice as large as the third angle is 10 degrees more than, right? So plus 10 is 10 degrees more than 7 times the smallest angle. So that's 7x. So now we've written everything in terms of x's, and we can think of our triangle as being x, y up here is just 2x, and then z down here is 7x minus 10. And now we have to find the measure of each angle, which requires us to understand what the hidden equation is, right? Every word problem has a hidden equation. Somewhere in here, this crap is related to each other in an equation. We just need to know what that is. And hopefully you know that the angles inside of a triangle always add up to 180. So it's just a matter of x plus 2x plus 7x minus 10 equals 180. Add them all together, 7, 8, 9, 10 of them, 10x minus 10 equals 180. Add 10, 10x equals 190, and of course x equals 19. Then you'd plug them back into here, right? This would be 38, and so on and so forth. All right, our last example. The distance around a circular garden is 188.4 feet. Find the radius to the nearest tenth of a foot, and they tell you to use this for pi. So they go, okay, they're talking about a circular garden. So here's my circle. And they tell me the distance around it is 188.4. And you go, okay, well, that's circumference. Circumference equals 188.4. And they want us to find the radius, right? So we're looking for the radius. So I've now basically labeled everything they told us. I need to know the formula for circumference. Circumference equals 2 pi times the radius. It's also sometimes written as pi times diameter, because the diameter is 2 times the radius. But since we're looking for the radius, we want everything in terms of the radius, it's better to use this version of circumference. So we just have 2 pi r equals 188.4. We got to solve for r, so we can divide both sides by 2 pi, because 2 pi is just a number, right? Pi is just a number, 3.14. So r equals 188.4 over 2, and then we got to put in the 3.14 here, and then do the math, and that will give us the radius that we're looking for. All right, that's everything I got for you guys.